So there's three types of systems. There's open, closed, and isolated systems, and they're actually pretty easy to define right here. So let's take a look at open systems. So in each of these examples, we are looking at these test tubes, and there's small changes to them. In an open system, you can think about a test tube, with the system being the contents in the test tube. And the test tube is open. There is no cap on it. That means it is free to exchange matter with the surrounding. Okay, the contents is free to exchange matter, meaning it could evaporate if you boil it. It can you can put stuff into the test tube because there's no cap, so matter can freely go in and out. And also, if you put it into like a hot environment, the system would take in that thermal energy. It would heat up and go up in temperature. Opposite is true. If you put it in a cold environment, the system would release that heat into the surrounding. So energy can also freely move in and out of the system. And that's what an open system is. Okay? Matter and energy can freely exchange. So that's the definition of an open system. In a closed system, it's implied in the name, you have a little cap that closes the tube. Now the system, it cannot get any matter from the outside. If you invert the tube, it doesn't spill out. So nothing can go in or out of it in terms of material matter. However, the thing is, this test tube is still made of like glass, usually. And glass is able to conduct heat. So if you put this test tube into like hot water, the system is still going to absorb that thermal energy. If you put the test tube in like snow, if you stuck it in snow, the system would release that energy into the snow and get colder, right? So this only allows energy to exchange. Matter cannot exchange, only energy can exchange. That's what a closed system is. So you can just imagine a lid on top of a container like this. Okay, so closed system, only energy can exchange. The last type of system, super simple. Isolated systems, and it's in the word isolated. It means like it's all by itself, right? So on this picture we have a cap, so material matter cannot go in or out. And we also have this coating on the outside. What is this? This is like insulation. Insulation is sometimes put on things when you do not want energy to either escape or you do not want energy to go in. Okay, so in an isolated system, matter and energy cannot transfer in or out of the system. So basically the system is isolated from the surrounding. Okay, that's where that word comes from. So try to relate these words to the definition, and then we're going to take a look at the examples. Okay, below we are going to again consider the ill child again, and what type of system each would be and why if the systems were defined to be, let's see, if the system was defined to be the ice pack itself, right? So when the system was the ice pack itself, the ice pack was able to transfer, or it was able to absorb energy from the child, from the kid who had a high fever. So it's able to absorb energy. However, the ice pack did not allow the contents inside to release its content, basically. So matter cannot go in or out. And this type of system is a closed system, okay? Because basically, matter could not be exchanged with the surrounding. Or you could say only energy exchanges with surrounding. Okay, either or. Okay. The second example we have the ill child is the system. Okay. If the kid is the system, is the focus, and everything else is surrounding, what was able to exchange? Well, energy was able to exchange because again, the kid loses that heat or transfers that heat into the ice pack, right? So energy is exchanged with the surrounding. And also the kid was breathing. the kid was releasing carbon dioxide into the surrounding and absorbing or breathing in oxygen from the surrounding as well. Also, the kid is releasing sweat into the surrounding. Very possible. So, if both energy and matter is transferring from the system to the surrounding, then it's an open system. Both matter and energy transfers. With surrounding. Okay. The last example, when we talked about when the thermometer itself was the system and everything else was the surrounding. Well, the thermometer was only able to increase in temperature in that example, right? So since the thermometer is in the kid's mouth, the kid, being really high in temperature, transfers that heat energy into the thermometer. However, since the thermometer is kind of like enclosed, then only energy can transfer. So I can just use the same explanation as before. So I can either say matter could not be exchanged with surrounding, or only energy exchanges for this example right here. Okay, so it's a closed system. Okay, there's some extra examples. I'm going to try to go through them so that you have more ideas to base this off of. So we're either going to say that this example is a open system, a closed system, or an isolated system. So the first one, it says, boiling a pot of water on an electric stove coil without a lid, with the system being the pot of water. Okay, so I like drawing pictures. Here's my pot of water. Here's a handle, right? And there's water in it, obviously. And it's being heated by an electric coil. Hopefully you've seen these before. They get real hot. They're on some kitchen stoves. So the pot of water is a system here. Could it gain or lose energy with surrounding? Well, it's definitely gaining energy from the coil, right? So energy can be exchanged with the surrounding. What about matter? Is it gaining or losing matter with the surrounding? Well, the most obvious example thing for this is that the water is probably going to be boiling, and we lose that water to the surrounding when it turns into steam, right? You can also technically put something into the pot as well, so you can be gaining matter as well. So in this type of system, you have an open system because it can gain and lose energy, and it can gain and lose mass or matter. So this is an open system. Alright, let's take a look at the next example, number 2. You will notice that it says almost the same thing. Boiling a pot of water on an electric stove coil without a lid, with the system being the electric stove coil. Okay, so we're looking at the coil being the system instead. Okay, well, can energy and matter transfer in and out of the coil? We're asking basically that. The coil, when it gets hot, it loses energy to the surrounding. It loses that energy and transfers it to the pot of water. It also transfers it to the air. So yeah, it's definitely exchanging energy with the surrounding. But is it exchanging mass? Well, the coil itself, is pretty much a piece of metal, right? And inside we have a wire that's also metal, and it's heating up. So there isn't really no mass that's going into the coil, and there's really no mass that's coming out of the coil, right? It's still a coil. You can reuse this almost indefinitely. So since only energy is transferring from the coil to the surrounding, then we're going to call this a closed system. There is no matter transferring. Right? This is going to be a closed system. Okay, excellent. We're going to take a look at number 3 now. Number 3. Ice water inside a closed and insulated bottle, such as a hydro flask, with the system being the ice and water. My mistake. The system is the ice and the water. So I'm going to draw a real quick picture of this. We've got a hydro flask. Hopefully you know what that is. It's a container that's really good at keeping things cold and keeping things hot, basically. Right? Okay, there's my hydro flask. There's water in it, and it's ice water. So I'm going to draw ice cubes floating on top. Okay, so the system in this one is the water and ice. Okay, both the water and the ice. Well, since this is in a hydro flask, energy really cannot go into the flask, right? Because if energy goes into the flask, that means that the hydro flask would be at room temperature pretty quickly. But in a hydro flask, if you put ice water into it, like even after the entire day, and you open the hydro flask finally at the end of the day, it's still going to be ice water. That's how good it is at insulating it, right? So that means energy could not go in. Same thing as if there was hot water in a hydro flask. So if you fill it in the morning with hot water and you close it, and then you open the hydro flask at the end of the night, it's still going to be hot water. That's how good a hydro flask is, all right? Assuming you never open it throughout the day. So it keeps energy from going in, and it keeps energy from going out. Also, since it's closed with a lid, that means matter cannot go out. So if you have a hydro flask like this one, and you tip it, matter cannot go out. Matter cannot go in either. Okay, so in this example, nothing is going in or out. Both energy and matter cannot go in or out, so we have an isolated system. Alright, it's an isolated system. Okay, let's look at the next example. In the next example, for number 4, we have ice water inside of a closed and insulated bottle, such as a hydro flask. So same example, with the system being the water only. Okay, so there's ice and water inside, but we're talking only about the water as the subject of focus. That means everything else, including the ice, is the surrounding, right? So I'm going to draw a real quick picture of this. I'm zooming in, and we got water and ice, right? For the sake of time, I'll just draw 2 ice cubes. Okay, so water and ice. So only the water is the system now. Only the water is the system. That means the ice is part of the surrounding. Well, is there any energy transfer from the water to the surrounding? Well, there definitely is, right? The water is losing heat energy to the ice. The water is losing heat energy to the ice, and then the ice will eventually, melt a little bit. It'll get a little bit less cold. It'll heat up, basically. What about matter? Is there any transfer from the system to the surrounding? Well, for this one, there is no additional matter coming from anywhere. Okay, so this is an example of only energy being able to transfer inside this hydro flask. If just the water is a system. Okay, so we're gonna say, okay, this one is a closed system. Only energy can transfer. Right, the very last one is an interesting one too. Let's look at the very last example. It says the Earth within space, with the system being the Earth and its atmosphere. So let's draw a real quick picture of this. I'm going to draw it on the bottom this time. There's my perfect circle. Here's one of the continents, Africa. I've got Europe, and then Asia. And then there's Russia right there. There's Australia down here. And then there's North America. I can't quite fit South America because it's on the other side of the globe. Right? And then the atmosphere is outside of Earth. The atmosphere, don't quote me on this, I think it's something around like 20 miles up in the sky, right? So this contains all of the air, right? And then outside we got cold, hard space. It's not hard, technically, because there's literally nothing in space. Space is a vacuum. It's an empty void. Okay, if the Earth is the system, if the Earth and the atmosphere is a system, what kind of system is it? Is it an open system, closed, or isolated? So we think about, okay, energy and matter. Is there any energy and matter that's going in and out to the surroundings, right? Well, where does the Earth get its energy from? It gets it from the big old star in the sky, closest one to us, aka the sun, right? So that sun is sending energy into the Earth. So there's definitely energy coming from the surrounding. Okay, what about matter? Is there matter that's being transferred into the Earth or out of the Earth? Matter is anything that has mass, right? So some students might think, okay, there's asteroids in space, and sometimes it hits and it goes into the Earth and hits the ground, Mr. Ta. That's made of matter. Definitely, asteroids are made of matter. Is there anything that leaves the Earth? Rocket ships, right? Or satellites. Rocket ships or satellites. I'm going to draw a satellite here. Those definitely leave the Earth. I don't know how to draw a satellite. Is that a satellite? Beep boop. Okay, that's a satellite. So those leave the Earth, and those are technically made of matter, right? Not technically, they are made of matter. So that's leaving the system to the surrounding. That's exactly it. So both matter and energy can be exchanged from this big system. So we would call this a open system. However, if you argued that, okay, Mr. Ta, the asteroids and the satellites, in comparison to the Earth, it's so small, right? It's like 0.000000001% of the mass of the Earth. It's barely anything. It's negligible. Yeah, if you can make that argument, you can say that since there is so less matter being exchanged with space, exchanged with the surrounding, you can make the argument that this is a closed system. Okay, so you can also say this is a closed system since that's arguable, since so less matter is being exchanged relative to what the system's size is. Okay, you can also make that argument. In fact, if you look online, some people argue that. Some people argue that, okay, the Earth is actually a closed system. And, they may not necessarily be wrong. Okay? So there's a little bit more practice. I want you to go ahead and try those. You have 5 tries. You know the drill.